Hi everyone, I'm Jane Hahn, and if you're at this session, you're likely a mortgage customer, or you process a lot of mortgage loan packages, interested in automating your mortgage document processing workflows with AI ML technologies. You're interested in hearing about our new feature, Analyze Lending from Amazon Textract, and you're excited to hear from Eric from Pennymac and how they automated their own mortgage document processing workflows. Again, I'm Jane Hahn. I'm a Senior Product Manager at Amazon Web Services, and I'm here to co-present the session with Eric Barrow, Senior Vice President of Application Development at Pennymac. Briefly going over today's agenda, I'll be talking about some of the legacy ways and challenges of document processing. Then I'll be talking about what is intelligent document processing, or IDP, and how that can help you automate your own workflows. I'll be providing an overview of Amazon Textract and some of its features and capabilities. Then I'm excited to share about Analyze Lending from Amazon Textract, our newest feature to help you accelerate your own document processing workflows. Then I'll invite Eric to come and share about how Pennymac faced some of their challenges and legacy ways of document processing and use AI ML technologies to accelerate their workflows. Legacy document processing doesn't necessarily meet today's needs. Traditionally, documents are processed in one of three ways, each with its own set of challenges and issues. First, there's legacy OCR, or optical character recognition, which is commonly used in many business workflows today, but they're mostly used on simple documents, as the response is like a blob of text where the structure of the document is stripped of its paragraphs or lines. This can be really challenging, as it can be error-prone and time-consuming way to process documents. Second, there's manual processing, where it can be really costly and time-consuming, as you may have millions of pages to process, so it's difficult to scale. Third, there is rules and template-based configuration, which can be really brittle, as new versions of templates are produced, and there's a lot of development and managed overhead to do that, which can really slow down your business's decision-making process. There are also hidden costs to legacy ways of document processing and maintaining these systems, such as impacts to top-line revenue, higher costs, and overall risks to maintaining the status quo. Especially in changing economic times like these, for example, you could have limited capacity to scale your business quickly and gain that business that your organization is looking for. Costs can mount as the staff that you have on hand aren't actually being utilized on these value-add activities, but they're being used on these undifferentiated workloads like data entry or manual processing. Technical debt also can mount on maintaining legacy systems, as they can pose higher security risks, which can lead to compliance issues or more disruptions to your business, which means that you're spending more time and effort in making those fixes on legacy systems. This can cause more churn to your business, and you can find that there are higher barriers as you want to make each change or fix or improvement while you're maintaining legacy systems, and this can overall impact your own client or customer satisfaction. So how do we solve this? I'd like to talk about intelligent document processing with AWS services like Amazon Textract. Amazon Textract takes advantage of advanced computer vision, natural language processing, and other machine learning innovations that we've developed over the years to help you go beyond what traditional OCR technologies can achieve. Amazon Textract provides structured outputs like key value pairings, tables, and cells within a table extraction. It covers a wide variety, long tail of document types, regardless of structure or layout. Amazon Textract doesn't require any machine learning expertise, as you can utilize one of our APIs that are fully managed. They are easy to integrate with and globally available, so that you can immediately begin reducing your reliance on manual processing. Moreover, it doesn't require any template configuration or management. And you can also reduce the amount of software or infrastructure management you might normally have had to maintain on legacy OCR software. The reduction in manual effort leads to a lot of benefits, such as improved accuracy, cost savings, and the ability to make decisions more quickly with Amazon Textract features. You may be already familiar with some of our features like OCR, text extraction, but we also support handwritten extraction as well. And we also offer that structured output that I was mentioning with the key value pairings like forms and tables. We also really listen to our customers when they share that they want more rich, domain-specific inferences from specialized document types like identity documents and invoices and receipts. So we have two different APIs that can support in this manner. They are Amazon Textract Analyze ID and Amazon Textract Analyze Expense. Starting first with Analyze ID, it is specially trained on identity documents like US driver's licenses and US passports. It can also extract inferred or implied information that may not be explicit. For example, a US driver's license may not actually state name or full name, but it can extract and infer that John Doe is the name on the driver's license and provide that structured key value output. Use cases for things for Analyze ID are things like online registration, billing, and identity verification. Next, I'll talk about Analyze Expense. Analyze Expense is specially trained on invoices and receipts and can be used on use cases like expense management, accounts payable, and billing, and other previously more difficult to automate document processing workflows. Lastly, I'd like to talk about Textract Queries, which is a new feature that we launched in just April of this year that enables customers to get more specific targeted extractions. For example, you can pose a natural language query or question to Textract Queries like, what is the customer name off of a given document? And you'll get that response back to you as John Doe as part of your API response. Here I wanted to just highlight some examples of what these extractions look like. So at the very top, you'll see that there is raw text extraction output, like your OCR. Right below it is that structured output I was mentioning with that key value pairing with forms, where you can see that the mortgage loan conventional, that checkbox is selected, and you have that value and key association. Right below it is tables recognition, where you can see that the structure of the tables is actually kept in place, where the column headers are gross monthly income, borrower, co-borrower, and total. And we're able to extract that cells within that table itself. We understand that in the mortgage lending industry, there is a wide variety of document types, and that there are challenges in extracting information within each document type itself, as there are many versions or different structures and layouts in the way things are displayed. Diving more deeply into some of the challenges that we see in mortgage loan data extraction, we really listen to our customers about their need for accuracy and the challenges that they face in extracting information from this wide variety of document types. I'd like to go over 5 of them today. First is document classification. We understand that there are many different document types, and it requires understanding what each page is so you know what information you want extracted from that page to get the critical information to run your business. This means customers invest heavily in manual processing, which can be time-consuming and error-prone, or they find they have to invest in in-house technology development, like custom-trained models, which can also be time-consuming and expensive to do. 2, there is data variations, where there can be a wide variety of data and how it's spread out and portrayed across these wide variety of document types. For example, what I mean as birthday can be portrayed as birth date or date of birth or DOB. And customers find they have to maintain a long list of synonyms in order to understand that this is all the same information that they're looking for across a wide variety of document types. This means it can be really error-prone and cumbersome to maintain as well. Third, there is data structure, where the structure of the information can be, again, widely different across the different document types, or even different within the same versions of the same document type itself. For example, to get gross pay year to date, or YTD, you may have to triangulate the column and the row headers just to get that information extracted, which can be challenging. Like I mentioned with the US driver's license example, not everything may be explicitly stated, so you would have to infer that the name John Doe was the name that you were looking to extract. There's also nested data, where it can be challenging to get the information from a section of page that may be deeply nested within the document. For example, you may want to extract social security number or date of birth, and then actually correctly associate it to the right respective applicant. As templates are brittle, this can be really challenging in order to appropriately extract the right information and associate it correctly. Lastly, I'd like to talk about routing and orchestration, where after all that pre-processing work is done, classifying the pages, understanding what document type it is, there's a lot of code development and logic maintenance that has to happen, so you can route that document type to the appropriate manual processor for data extraction, or to the right custom trained model you may have developed, so that you can get the right information you want from that document type. Overall, customers find that there's a lot of pre- and post-processing work that has to happen in order to get the information they want from that document type, which can be really error-prone, time-consuming, and costly to do. Apart from these challenges, there's an ever-changing regulatory landscape that can highlight some of the deficiencies and risks in maintaining these legacy systems. And customers are looking for a more secure solution that can help them in their own automation journey so that they can accelerate their document processing workflows, reduce costs by reducing reliance on manual processing, and make decisions quickly as they are able to scale. So I'm excited to share about Analyze Lending API from Amazon Textract, which is a new feature that we launched here just this week at reInvent. Analyze Lending enables customers to automate their data extraction workflow end-to-end. You simply upload a multi-hundred or multi-thousand page loan package even, and Analyze Lending API will classify each page. It will split it along its document boundary by document type. It will route it to the appropriate machine learning model so that you get the data extraction that you want from that relevant document type. It also detects signatures across the mortgage loan packages so that you understand where signatures are present and where they're missing. On top of extractions by document type, we also provide a summary page for each of the mortgage loan packages that you upload to our API that tells you, hey, these are the documents that we found. These are the documents that you expect to be in a typical mortgage loan application, but it's missing. These are where signatures are detected, and these are where signatures are missing where you know there should be one. Overall, Analyze Lending API is specially trained on commonly found mortgage document types, like W-2s, pay statements, pay slips, 1003s, 1005s, identity documents, and more. Now, I'd like to talk about a typical workflow for a mortgage loan package. Customers like yourselves find that you have hundreds of thousands of mortgage loan packages that you need to process annually, millions of pages you need to understand what they are and get the data extractions that you need. This means that customers like yourselves rely heavily on manual processing or a lot of in-house technical development and management in order to get this data extraction, this undifferentiated workload, and it can be time-consuming, error-prone, and costly. So with Analyze Lending API, you can simply upload your mortgage loan package, and the Analyze Lending API will classify each page. It will split it along its logical document boundary, like tax statement, wage statement, pay statements, and more. And then it will intelligently route it so that you actually get the right data extractions that you want by that document type. Like I mentioned, it detects signatures and it provides a summary page that you understand what documents were found, where signatures were present, and where they're all missing. I'd like to also highlight that Analyze Lending API provides normalized or standardized output responses where you can understand what information is associated with what key, even when it's not explicitly stated. With Analyze Lending API, you can simply automate your data extraction workflows. You can accelerate your mortgage processing workflows with accuracy, reduce your reliance on manual processing, and thereby save costs by an order of magnitude. And you can scale your business and remain agile in an ever-changing economic environment. Now I'd like to invite Eric to share about how Pennymac faced some of the challenges and legacy ways of document processing, how they utilize AWS services like Amazon Textract, and how they lean into new innovations like Analyze Lending.
Thanks, Jane. Hi, everybody. Thanks for coming out. I'm Eric Barrow. I manage a handful of development teams at Pennymac. And I'm super excited to be here today to talk to you guys about how we do document processing. For those of you who haven't heard of us, Pennymac is a financial services company focusing on every aspect of the mortgage industry. We buy, sell, create, services, mortgage documents. And in doing so, we deal with an awful lot of documentation, which causes a handful of unique challenges. But to understand those challenges, you really need to understand where these documents are coming from and the state they're in when we get them. So in the mortgage industry, there's something called correspondent lending. This is basically when a lender is buying mortgages from another lender and these mortgages have already been created. Pennymac is the #1 correspondent lender in the country. And so when we buy these loans, we're buying tens of thousands of these loans every month. And when we're analyzing them, we receive a single PDF called a complete loan package, which basically summarizes all of the mortgage documents that were gathered during the loan creation process. This PDF has no table of contents. There's no consistent order that we can rely on. There's no summarizing data set that comes along with it to tell us what's inside of it. And oftentimes, it's missing key documents that we need to make a purchase decision. When that happens, we need to reach out to our document custodian or the original lender and gather that information. So in correspondent lending, you're left with this scenario where you have this complete loan package with absolutely no contextual information in it, and a handful of conditional documents that we need to go gather. And that's how it is in correspondent lending. When we're doing direct lending, when we actually create the loans, it's a little bit different because we have some context for the loan, for the documents, excuse me. We're directly asking borrowers and brokers for the documents when we need them. The context doesn't solve everything. The open-endedness of these kind of document requests makes it difficult to organize everything. And so I came up with a toy example to try and illustrate this problem for you guys. Imagine, if you will, one of our associates is doing asset review and they're looking at a bank statement. And on that bank statement, there's a line item that shows a very large influx of cash. So we reach out to the borrower and we say, hey, can you give us a document that explains where this cash comes from? And let's say, for example, the borrower uploads the receipt of a boat sale. They had a boat, they sold it, and they got a bunch of money. Later on in our process, maybe another associate is doing liabilities review, and they see that that boat had a loan associated with it, and that loan got closed out when the boat was sold. That person doing liabilities review isn't going to know, there's nothing necessarily intuitive telling them that there was a receipt document that was uploaded with a bank statement that's associated with this particular line item. So they have to go find that document. And just compound that problem with a multitude of document requests throughout the life of creating the loan, and thousands of loans every month, and you kind of get the picture of how difficult it is to organize all of this. So in summary, when we're purchasing loans, you get a complete loan package and a bunch of arbitrary conditional documents that you need to combine together to understand. And when we're creating the loans, the context is fluid and it makes it difficult to organize. I estimate that we spend somewhere around $20 million a year in document management costs because of these difficulties. So when we're dealing with large packages of loans, the complete loan package, or really any batch of mortgage documents, we use a vendor. And this vendor gives us an SFTP endpoint, has an input folder and a complete folder. We drop documents off in the input folder, and they process them, giving us a data set table of contents, they index the document, and they load that into the complete folder. And this is fine for batch processing. When we have a bunch of arbitrary conditional documents that are at a high volume that we need to go and process, we run into some issues. First, there's no direct control of the process. Right? So if I upload documents into this input folder and they don't come back in the complete folder, I have to call the vendor. Second, it's kind of an inappropriate technology for a bunch of small continuous requests. Right? So I'm either in a position where I need to batch up all of these small documents, or I run the risk of making too many concurrent requests to the service and potentially throttling it. And then lastly, there's no immediate feedback. Right? So oftentimes borrowers are uploading things that we don't actually expect to get. And when that happens, we need to reach out to them and ask them for something else. But we can't do that until we really understand what it is they gave us in the first place. So we want to tighten that feedback loop as much as possible. So how did we solve for that? Well, based off of where you are, you probably guessed we built a bunch of services using AWS. We built out an assembly service that basically takes the documents and forces them into the most conducive format for us to do our work. It also picks up some contextual information, things like who uploaded this, why did they upload it, and when. We're using Textract for our OCR solution, but we built an orchestration architecture on top of that. We have a mortgage document classifier that currently can handle around 350 different mortgage document types. We predict documents at the page level. So if we get a package of documents, it helps us understand the borders of those documents and what kind of documents are inside the package. But it also allows us to do these arbitrary single uploads as well. We index docs with a service devoted to that. Indexing is effectively just adding a clickable table of contents to a PDF, but it's also reordering it to be in a format that's most performant for our flow. And lastly, we harvest data. Right? So we're taking the predictions from our mortgage document classifier, we're taking the raw text from the Textract service, and we're building out a normalized data set that we can use to either patch into our loan origination system or use it to train other models to automate our loan origination flow. So all these services really rely on robust and accurate OCR, and we definitely get that from AWS Textract. Over the life of building out these applications, we've tried a handful of different OCR services. Textract is definitely one of the most accurate, but it is far and away the most functional. We get things like forms and tables. This allows us a semi-structured response for all the forms and table data we get in our standardized documentation. It has Textract queries, which we're actively looking at to solve our versioning problem. Textract queries, for those of you who don't know, allows you to do a natural language question for a document and receive data points in the response. Excuse me. And so with this versioning problem that we have, oftentimes when we get a package of documents, some of those documents are redundant. Imagine, if you will, that we ask the borrower for 3 years of bank statements, and we need to know which one is the most recent bank statement. Textract queries would allow us to solve that, because we can ask questions of those documents and receive the created date of all the bank statements, for instance. One of the things that's not mentioned, I don't think too often, but it's been particularly helpful for us, is there's a handful of open source libraries that help you interact with the response from Textract. If you haven't seen the response from a Textract API call, it's super verbose. Right? It's giving you the X and Y coordinates for the letter T, and the X and Y coordinates for the word that the letter T exists in the paragraph that the word is on the page that it's on. So you get this massive block information that you got to parse through, and it can be fairly arduous if you're just doing it from scratch. So things like the Textract response parser library helps you take a handful of functions and just kind of clean that response up to give you a single queryable response. But to use Textract at the scale that we're using it, we really needed to build out an orchestration architecture on top of it. So what we did is we built out an API that allows a user or a system to upload a document of any size, have that document be processed and turned into a single JSON payload that we can then query from a GET response on our API. To do that, we use technologies like AWS step functions, Lambda, DynamoDB, S3. Effectively, what happens is someone uploads a document. Well, they call our API, they get a pre-signed URL to upload a document into an S3 bucket. Document hits the S3 bucket, and that triggers our step function. First thing in our step function reads the document and determines how large it is. and then breaks that document into chunks of around 200 megabytes. We're doing that for two reasons. One, because a consistent payload size seemed to be the most performant for the service. And second, we didn't want to run afoul of the size limitations of the service. Textract only allows you to upload a document of 500 megabytes or less, or 3,000 pages or less. And these complete loan packages, surprisingly, oftentimes come in much larger than that. So once we break the document into chunks, we pass it to a step function map state, which is a functionality that allows you to make Lambda function calls for every item in an array. So we run the map state. We run each chunk as an individual Textract job. We're using step functions await tokens to know when all those jobs are done. And when they are done, the next part of the process kicks off, and we use the Textract response parser to clean that response, turn it into a single JSON payload, and store it for anybody to query it. Of course, once you have OCR, things like indexing, harvesting, document classification, all these things are possible. They're possible, but they're not necessarily easy. To give you a sense of the scale of our problem for document classification, for instance, Pennymac over the years has amassed millions of these complete loan packages. My team took about 300,000 of them, made a data set that we had to clean, parse, and train our models on. These complete loan packages, they average around 600 pages each with a really fat right tail to that average. So you can imagine it's at least 180 million pages of mortgage documentation that we had to work with. This is where SageMaker really shined for us. So first, it allowed us to build a model creation pipeline. This pipeline allows us to break up the data. We have a pre-processing job that breaks that data into 3 partitions, 2 for training, 1 for test. We have a job that does hyperparameter tuning. It's on distributed architecture. It's basically running different models with different parameter configurations to find the best fit one. We have an evaluation job that takes that best fit model and runs it against our test partition. The test partition, after we run that evaluation job, those metrics are stored in a CloudWatch dashboard for later use. And eventually we're parking the model registry artifacts. Eventually we're parking the artifacts that are created from the training job in the SageMaker model registry. So the first benefit of SageMaker to us was that we didn't have to really learn any cloud formation. We didn't have to learn Kubernetes. We didn't have to work with Kubeflow or anything like that to build out this pipeline. We just use the SageMaker SDK and a single module of code, a handful of classes and functions that define this pipeline and allow us to run it on demand when we need it, which has been particularly useful. So that's one way it's helped us. Another way is that SageMaker plays really well with everything else in the AWS ecosystem. For instance, this pipeline exists within the context of a model deployment pipeline. It looks something like this. So we have a data lake. Live data is going into that data lake. Imagine, if you will, our models mislabel a W-2 document as a pay stub or something like that. Or our business partners are asking us to train our models on a document that we haven't trained on before. My data scientists can see the data in the data lake, and if they need to retrain, they simply do a pull request against our code commit repo. That's tied to that SageMaker model creation pipeline, so once they make that pull request, that triggers that pipeline off. Model artifacts end up in the SageMaker model registry, and the evaluation metrics, as I mentioned, go into a CloudWatch dashboard. The model registry has been particularly useful because it allows us to see new versions of the models coming in, and it gives us a hook where we could say approve or decline based off of what we see in our evaluation metrics. So if our data scientists go in and see recall and precision and those kind of things that they like, they can approve the new model version. And that's going to trigger off a message. We take a message and we stick it into EventBridge, which is being listened to by a code pipeline. And this code pipeline does 2 things. First thing it does is it deploys the models to a staging environment. This is great because in that staging environment, we're actually doing live inference requests. So we can see if our models generalize well against reality. If you've done this work, you know that there's this kind of eternal fear that you've trained really well on your data set, but that doesn't necessarily translate perfectly to reality. So this is a particularly useful step for us. Within the code pipeline, we have another approval step. So if we like what we see, we can approve that. And the second part of our pipeline will kick off and deploy that model into our production account as a live model, as part of our system. Now, using this architecture, we've been able to build out about 17 models. We have a supercategory model, which takes the raw OCR output and associates that with a subcategory model. We have subcategory models that are trained on different document domains. So just to kind of go through the benefits of SageMaker for this system, right? First, it allowed us to build out an incredibly flexible pipeline. If I came to my team tomorrow and said we're doing fraud detection instead of mortgage document classification, and we're going to use tabular data sets instead of NLP, architecturally speaking, I wouldn't have to change anything. Our code deployment pipeline would be the exact same. Our model creation pipeline would generally be the same. We'd have to code new pre-processing steps and new training scripts, but the machinations around it all remain the same. So we have a factory where we can just pump out models now. Second is scale, right? I mentioned earlier that we can do 350 different document types. That's what we can predict. That represents all of the documents in the complete loan package that are about 90% frequent or less, or more, sorry. So the remaining, there's 1,000 or so remaining that we still have to predict, but those show up less than 10% of the time. So that 350 that we get are the core documents that really represent the nature of the loan, the borrower, and the property. And lastly, speed. Speed is both a consequence of how great SageMaker is and how freakishly awesome my team has been. But just to give you a sense of how quick this happened, we started this project in November of last year and went to production in June. And that's with a team that averaged about 8 people in size. So it's been particularly helpful. I don't want to talk about every single one of my microservices. There isn't time for all of that, but I did want to touch on how we're doing this data harvesting work. So for this effort, we're using something called the GeoFinder library. If you look on the screen, what you're seeing is the first page of an ERLA document. And on that page, you see that there's borrower and co-borrower. If you were to look at the raw response from Textract for this, you would get 2 sets of social security number fields, 2 sets of date of birth, 2 sets of married, unmarried, and separated. But you wouldn't be able to associate any of those sets with either borrower or co-borrower. In fact, they might just show up arbitrarily in the block information, so you'd have to kind of reassemble them. And that's what the GeoFinder library does. I mentioned before that the responsive Textract is pretty verbose. You're literally getting the X and Y coordinates for individual characters and words and things like that. So the GeoFinder gives you the ability to say, hey, on page 1, there's a phrase that says borrower information, and next to that, there's a phrase that says co-borrower. I want you to find that phrase, and then find all the fields geometrically near it, using those X and Y coordinates. So doing that, I could say, hey, go get co-borrower and go get me the fields under it. And now I know that the married field on that is the co-borrower married field. And the social security is the co-borrower social security. So it gives you the ability to have context to the response you're having, which otherwise is a fairly unbounded and massive problem to solve. It's just another example of how the tooling in AWS helps you build out something like an intelligent document processing platform, just by assembling all those pieces together. It's not all been roses, though. Some of this has been fairly difficult, and we're building that harvesting code based off of where phrases exist in standardized documents. So if those documents change, we got to write new code. I mentioned before we did the 350 document types, and that there's still thousands left. Well, that's thousands left. That's more training work that my team has to do, and it's an awful lot of work. This is where we're looking at Analyze Lending API. So as Jane pointed out in her talk, this is going to give us basically 2 of our microservices behind a single API endpoint. It's going to allow us to classify mortgage documents with confidence scores and deliver to us a normalized data set. That's going to drastically decrease complexity for those documents that we find in the service. It's also going to accelerate us to going to market with different features, so it's particularly useful. I'm definitely excited to see what AWS does with this service and how my team can use it in the future. And with that, I'd like to hand it back to Jane to close this out.
Thank you, Eric, so much for sharing the journey of Pennymac and how they face some of these challenges and legacy ways of document processing, how you utilized AWS services like Amazon Textract, and how you lean into new innovations like Analyze Lending. I'd like to talk about some of the partners we have in our AWS network that can help you get started in your digital transformation journey, no matter what stage you and your business may be in. Our AWS partner network are well-versed in AWS services like Amazon Textract and can help you get started in new features like Analyze Lending. Lastly, I'd like to leave you with some important resources that can help you get started. Please feel free to visit our Amazon Textract service page. There you can check out a demo console we have for Analyze Lending, where you can test out the different mortgage document types that can be classified, split by document type, where the signatures are detected, and the extractions that are normalized and standardized, you can visualize them on the demo console. We also have GitHub, where you can find code source links, as well as different blog posts that can help you get started on Amazon Textract or other AI ML technologies. I'd like to thank Eric once again from Pennymac for joining me on stage and co-presenting this session with me, sharing the story about how they automated their mortgage document processing workflows with AI ML technologies at AWS. And I want to thank you all so much for joining us today and hearing about the automation journey, and hope you have a great reInvent. We'll be sticking around, I think towards the back, if you have any questions. Thank you so much.